Is the collision elastic or inelastic? Explain the answer by means of suitable calculations. We have all the necessary information required to solve the question. This information is displayed in the diagrams on the screen. The values you see on these diagrams have either been provided in the question's preamble or have been calculated in the previous sub-questions. As the question outlines, there are two types of collisions, elastic and inelastic. What they share in common is the conservation of total linear momentum. However, they diverge when it comes to the conservation of total kinetic energy. In elastic collisions, total kinetic energy remains constant, while in inelastic collisions, it undergoes change. To determine whether this collision is elastic or inelastic, we need to calculate the total kinetic energies before and after the collision and then make a comparison. Kinetic energy is calculated as half of the mass of an object multiplied by the square of its velocity. The total kinetic energy before the collision is the sum of the kinetic energies of trolley X and Y in the first diagram. For trolley X, its kinetic energy is computed as half of its mass 1.2 kilograms multiplied by the square of its velocity 8 meters per second. Trolley Y, initially at rest, has a kinetic energy of 0. Adding these two values together yields a total kinetic energy of 38.4 joules. After the collision, the total kinetic energy is determined by adding up the kinetic energies of trolley X and Y in the second diagram. The kinetic energy of trolley X is calculated as half of its mass 1.2 kilograms multiplied by the square of its final velocity 4 meters per second. Trolley Y's kinetic energy is computed as half of its mass 0.5 kilograms multiplied by the square of its final velocity 9.6 meters per second. The kinetic energy of trolley X is 9.6 joules and that of trolley Y is 23.04 joules. The sum of these values results in a total kinetic energy of 32.64 joules. It is evident that the initial and final total kinetic energies differ, specifically 38.4 joules and 32.64 joules are not equal. Thus, we can conclude that this collision is in fact an inelastic one. To break down the marking criteria, you earn 1 mark for correctly applying the kinetic energy formula. Another mark is awarded for accurately substituting values to calculate the total kinetic energy before the collision. 1 more mark is granted for precise substitution of the values to compute the total kinetic energy after the collision. You receive an additional mark for clearly stating that these values are not equal. Lastly, the final mark is allocated for correctly identifying this collision as an inelastic one.